Welcome back to Code Meets World. Today we're going to be looking at another math and geometry problem. This one's called Set Matrix Zeros, and it is LeetCode number 73. You'll actually notice the NeetCode interface looks a little bit different because they just released a big update, and now this stuff is configurable, which is pretty cool. But anyway, this problem says, given an m by n integer matrix, if an element is 0, we need to set its entire row and columns to zeros, and you must do that in place. So let's see if we have some examples. I see the test cases. Okay, so in this given matrix on the left, there's 1, 0, and we're told that when we see a 0, all the rows and columns need to go to 0. So everything, because there's a 0 here, we set that whole row and its whole column all to zeros. Here's another example. So because there are 2 zeros, we have to take all the values in the column that this 0 is in and make them zeros. The row, make them zeros. And then same thing for this one. It impacts this row, which already got turned to zeros, so it just stays all zeros, and then this column, zeros. And I think this in-place requirement is what's going to make this interesting. But let's go ahead and talk about what we can do here. So let me just use the example that they gave, which was just a 0 in the middle. Whoops. Like this. And so we know what has to happen, but how can we do that programmatically? What comes to mind immediately is to keep track of where the zeros are in the matrix on a first pass, and then make a second pass to convert the values into zeros that need to be zeros. So what I mean is, say we have an array or something to keep track of where the zeros are. And so say we iterate through this matrix, and when we get to the 0, that's at index 1, 1. So we could store that in a list somewhere, and then we would finish going through. That would be the only 0. So then once we finish, we could go back and iterate through the list of all the zeros. So I'll just call this zeros. We could go iterate through the zeros list and say, okay, we know that anything in this list, we need to convert that whole row or column into zeros. So in this case, first we see that row 1 of the matrix, which is here, that had a 0 in it. So that means I need to switch all the values in that row to zeros. Then we see that column 1 also had a 0. So that's here. And again, we do the same thing. We switch those to zeros, and we're done. That one is pretty straightforward. So that's a perfectly valid way to solve this problem. But the one issue is that the problem statement told us to do this all in place, which means without making another matrix. And we did that, but we used this extra array to keep track of where all the zeros are. And because we did that, I don't think we've technically used as little space as we could have. So I also wanted to think about a solution that would allow us to solve the problem, but without using any extra arrays to keep track of where all the zeros are. What I'm saying is, I think we can keep track of what rows and columns have zeros in them using the matrix itself and nothing else. So let me show you how I think we can do that. So I'll start out with the same problem we've been looking at. And move the 0 a bit. What we can do is use, I think this will work. I think we can use the first column and the first row to keep track of what rows and what columns need to turn all to zeros at the end. Because remember, also, we can't just, when we see a zero, like say we're iterating through the array, originally I was thinking, oh, as soon as we see a zero, let's just change the rows and the columns to zeros right away. But you can't do that on the first pass, because once you change something to a zero, now you don't know when you see another zero, is that one of the original zeros or is that one of the ones that I've added, and you won't be able to solve the problem. So you have to go through first and mark where all the zeros are, and then update the columns and rows after you've done all that. So what I'm saying is, I think we can use the first row and the first column to mark which rows and columns have zeros. So let's see what I mean by that. So when we're going through and we see, oh, okay, there's a zero in the middle, let's mark that there's a zero by making the first row a zero in that position and the first column a zero in that position. We're marking that there's a zero in that row, that column position. So then that's the only zero, so now we're done. And now the second part is, now we can iterate over every value in the matrix and say, hey, when I get to this value, am I in one of the marked rows or columns? Because if I am, I need to change to a zero. So we start out at the top with the one here, and that one's actually a special case because it doesn't have a marker. The first row and first column are a special case, and I think we need to handle that maybe with a variable. I'll talk about that in a second. So we can't really check the first row and the first column because those are our marker rows, and I'll talk about how to do that in a second. But for all of our internal values, so this one, is it in a row or column that is marked by a zero? Well, yes, it is, but it's already a zero, so that's good. Then we get to this one here. Is this in a row or column that's been marked with a zero? Yes, because look, there's a zero right there. So that means we need to make this into a zero. And now we come down to here, and again, that's going to be the special case. Then we get to this one. And yes, this is in a column that has been marked with a zero. So we can update this one to be zero, and then this one at the end here, if you look, it has a 1 here and a 1 here, so there's no zero markers, so we leave that one alone. And that actually solves the problem. We're left with the final answer that we want. Now, I put this question mark here, because how do we handle, let me use a different color, how do we handle knowing when to update the first row and the first column? Well, I think what we could do is simply have some sort of Boolean flag for first row and first column. And if we see a zero in those at any point, we can just set the flag to true. And then we know if we set the flag to true, we have to convert the whole row or column to zero. And we can do that at the end as well. So this is a little bit confusing in my opinion, so let's look at the second example. So this is the other problem. Let's work through how this would go with the technique I just described. So again, we need to keep our eyes on all the values here to use as our marker, and then we also have those flags for first row and for first column. So in this case, we can see straight away that the first row has zeros in it and the first column has a zero in it. So we can set both of these to true, which will come into play at the end. Then, when we're going through and iterating over everything, when we get to this first zero, we have to say, okay, let's set its row and its column marker to zero. remember, this is one of the weird ones. It doesn't really have a marker, so we don't do anything. And funny enough, same for this 0. It doesn't really have a column marker because it's not anything that's in the green. We can't really set a mark for 0. We have to use this technique instead for everything in the green. So actually, let me rewrite this as green, so that makes more sense. So the first row, first column. So everything in green controls itself. So these flags are going to be used to update the stuff that's in green. Everything down here in red, we mark if these should be 0s by updating the stuff in the green. But in this case, we actually don't have any values in the red that we need to update. So we actually just don't do anything here. And then when we get to the second part of the algorithm, where we just go through every value in the red and say, hey, is this in a row or a column that has a 0 marker? And so for the first one, no, the row and the column marker are both 1, so we don't change this one. For this one here, same thing, we don't change it. For this one and this one, they have a 0 in the row marker, so then we could change both of these to 0. And that's it. The other ones also, these ones don't get updated because there are no 0s. And then at the end, we use these flags to say, okay, we need to change the first row to all 0s. So we do that. And then this flag tells us we need to change the first column to all 0s. And so we do that. And then that's our final answer. One other thing to note is that if, for example, if I back up, if there had been, say, a 0 here at any point, then what we would have done is update both of these to be 0s in the first part of the algorithm. And then that would have enabled later on this one to be updated to a 0, as well as this one. And so that's just an illustration of how it would work in the full case. This is a really interesting and unique problem. I don't think I've ever really done anything like this, but let's see if we can figure this out in the code. I'll keep the whiteboard up just because I think it's a useful visualization to have in case we need to talk through anything. But yeah, let's go ahead and give the code a try. So anytime we're working with a matrix, I like to define m and n as the length of the matrix, so basically the number of rows, and n is the number of columns, which will just be the length of any of the rows of the matrix. And we're not sure how big it is, so I can just always check the first row. Now we need to loop over everything and track where all the 0s are, like we just talked about. So we can say for I in range m, so loop over all the rows, and then we'll do the same thing for the columns. So we'll loop over n for the columns. And then what we need to do here is check if we see a 0. So if matrix ij equals 0, if that happens, we need to set column and row, I'm calling them markers, to 0, like I showed on the whiteboard. So everything in the green. So basically, if I see anything in the red that's a 0, I need to set the outer values in the green to 0 to mark that. So how I'll do that is I will say, let's see. So I need to set each of them. So I need to say that matrix, first I'll set the first column value. So we know that that would be in column 0, row I, we would set that equal to 0. So again, that's setting, back over on the whiteboard, that's setting one of the values in this column on the left to 0, because we know that it would be column 0 and then row whatever we're on, which is I. We'll do the same thing for, because when we see a 0, we need to set both the column, the first column, and the first row to mark that it's a 0. So it's just the reverse of that, like so. So that would set the value in the first row, whatever column J is referring to. So that would set the value up there at the top. The other thing I mentioned, right, are these flags over here. So we also need to have those. I forgot to put them at the top. So I will say, I'll call one, just for clarity, 0 in first row. I'll set that equal to false to start. And then we'll have a 0 in first column, and we'll set that equal to false as well. And then down here, what we can say is if we see a 0 and I is 0, so we're already in the case where we found a 0. If that 0 is in the first row, we need to set that flag, 0 in first row, to true. And we can do the same thing if J is 0, meaning it's in the first column. We can say 0 in first column equals true. Great. So that's it for the first pass. Now that we've done that, we need to now loop back over everything. And if a value falls in a row or column that's been marked as a 0, basically we're going to loop over everything in the red. Yeah, we're going to loop over everything in the red and set anything to be a 0 that needs to be a 0. So to do that, we can say for I in range, and again, we want to skip the first row, skip the first column. So we can say for I in range n plus 1. Yeah. And then we can say for j in range n plus 1. Because we just want to consider everything in the red, as you see on the whiteboard. So then here, for every single value, we need to check if it's in a column or row that we marked as a 0. So then we can say if matrix, and again, using these values here, right? So if matrix I 0 equals 0, or matrix 0 j equals 0. If either of those are true, then we need to set the value that we're at, matrix ij. We need to set that equal to 0. Hopefully that makes sense. If either the row or the column we've marked as a 0, we set that value to 0, like I described when I was showing it on the whiteboard. Right. I think that's all we have to do there. And then the last step is to consider the flags. So if there's a 0 in the first row, we can simply replace the first row with all zeros. So I guess I could actually do a cool trick here and say matrix 0 equals an array of zeros times the number of columns. So that's gonna, this part here creates an array of length n that's all zeros, and I'll just put that in for matrix 0, so the first row. I don't think there's a cool trick to do that with columns because they're not really connected in the same way that rows are in memory. So I can say if there's a 0 in the first column, I think I just have to loop. So I can say for I in a range, and we have to loop over to update the whole first column, we have to loop over all the rows, which is m. For I in range m, we need to set matrix row is I, the column will stay 0. We set that to 0. All right, so let's see if I've made any syntax or logical errors. It seems I have. What does it say? List index out of range. Oh, right. I'm not trying to do m+1, I'm trying to do m. I'm sorry, yeah, okay. I'm trying to go from 1 to m and from 1 to n. Sorry, I had the syntax wrong there. I think that's better. What I was doing before was definitely not right. I was just looping over rows +1 and columns +1. That's not what I wanted to do at all. So that gave us an error. Okay, great. Let me make this a bit bigger. That's passing both the test cases, which is fantastic. So let's go ahead and submit and see if we got it. Yeah. Wow, look at this. 99.2 percentile for runtime and 92 percentile for memory. I think that would be the highest I've ever had. So great. I feel like that proves that this is a good way to think about it. And yeah, the memory usage here is really low, which is because we didn't use these flags. Maybe there's a way to do it where you don't use these at all either. But I couldn't think of a good way to do that here. So yeah, hopefully that makes sense. This was a really interesting problem, and I will see you in the next video.